Today we're discussing the article titled LoRAMoE, Alleviate World Knowledge Forgetting in Large Language Models via MoE-Style plugin.
So this paper dives into the challenges of supervised fine-tuning for large language models and how it can sometimes lead to a loss of world knowledge while trying to improve task performance. The authors propose a new framework called LoRAMoE to tackle this issue. Mira, could you tell us more about the main problem the paper is addressing and what LoRAMoE contributes to solving it?
Sure, Jensen. The paper highlights the conflict between scaling instruction data to enhance task performance and retaining world knowledge in large language models. LoRAMoE introduces a mixture of expert-style plugin with low-rank adapters to address this, aiming to improve task performance without losing stored world knowledge.
Interesting. Now let's explore the motivation behind this study. What impact does large-scale supervised fine-tuning have on these models?
Well, the study shows that while fine-tuning improves performance on tasks like summarization and translation, it causes a decline in closed-book QA tasks, which are crucial for world knowledge benchmarks. This decline is due to irreversible knowledge forgetting during fine-tuning.
Oh, that's concerning. Can you explain the diverging trend observed in the study?
Right. So the study used a dataset with 7 task categories and found that while some tasks improved, closed-book QA tasks declined significantly, especially with larger datasets. This suggests a trade-off between task performance and world knowledge retention.
I see. And what about the irreversible knowledge forgetting? How does that happen?
Yeah, it's quite an issue. Fine-tuning on CBQA datasets initially boosts performance but offers limited gains beyond a certain point. Sequential fine-tuning without CBQA data leads to a significant decline in knowledge capabilities, showing that large-scale tuning damages stored knowledge.
Thanks for clarifying that. Let's move on to LoRAMoE itself. How does this methodology work?
LoRAMoE uses a mixture of expert-style plugin with a localized balancing constraint. It freezes the backbone model to preserve world knowledge and uses experts to improve task performance. LoRA is used to enhance efficiency by reducing trainable parameters.
Got it. Could you elaborate on the architecture of LoRAMoE?
Absolutely. The architecture involves replacing the FFN block's linear layer with a MoE-style plugin. Experts collaborate on tasks, and a router assigns weights to them. LoRA reduces trainable parameters, making the process efficient and cost-effective.
That sounds efficient. What about the localized balancing constraint? How does it help?
Oh, it's quite clever. The constraint balances expert utilization by considering mixed data distributions. It ensures equal importance among experts within the same group, promoting cooperation and preserving generalization capacity.
Interesting approach. Now let's discuss the experiments conducted. How was the experiment set up for LoRAMoE?
The setup involved replacing the linear layer in LLMs with the LoRAMoE layer, using 6 experts per layer. Hyperparameters were carefully chosen, and only experts and routers were trainable, keeping the base model frozen.
Sounds thorough. What were the main results from these experiments?
Well, LoRAMoE outperformed both SFT and single LoRa tuning, showing significant improvements in world knowledge benchmarks and other tasks. It avoided catastrophic collapse and enhanced multitasking performance.
Impressive. Was there any sensitivity analysis conducted?
Yes, they did a sensitivity analysis. It showed that increasing trainable parameters generally maintain stable performance, with 6 experts being optimal. Increasing LoRa rank slightly improved capabilities, but increased parameters exponentially.
Good to know. And how do they visualize expert utilization?
Oh, they visualized it by showing how experts are employed differently for world knowledge versus other tasks. Routers allocate tasks to appropriate experts, ensuring effective utilization and preventing knowledge forgetting.
That's a comprehensive approach to understanding expert utilization.
Jensen, what's your overall take on the findings from this article?
Well, I think the paper presents a compelling solution to the challenge of balancing task performance and world knowledge retention. LoRAMoE's innovative use of experts and constraints seems promising for future developments in large language models.
Thanks for sharing your thoughts, Jensen. That's all for today's episode. Goodbye, everyone.
Goodbye, and thanks for tuning in. See you next time.